I am good. How are you?
Good.
Good.
What are we going to work on today?
We are working on the graphs of sine, cosine, tangent, and their amplitudes, periods, lifts, and shifts.
Okay, so the sinusoid function.
Mm.
Tell me if you've seen this. And is this the format that is your general format?
Yes, I've seen it, except B is inside the parentheses. Those are the only difference.
That actually makes a big difference. And some school systems do make it like this. And the big difference is the phase shift is different. In other words, the advantage of the number one format is that the phase shift is C. With the number two format, you have to factor out the B first, so the phase shift ends up being C divided by B.
Okay.
So depending on what form you're given the equation, determines on how you figure the phase shift. Everything else is the same. The amplitude is the same. The period determined by B is the same whether it's inside or outside the parentheses. And the vertical shift is the same. But the one thing that differs considerably is the phase shift. In other words, the horizontal shift.
Okay.
And depending on whether B is inside or outside the parentheses. All right, you got some specific problems?
Yeah. So for the first couple, it wants us to describe how the graphs of f of x and g of x are related, and then find the amplitude of g of x, and sketch the two periods of both the functions on the same coordinate axis.
Okay. What's f of x?
F of x is sine x, and then g of x is 1/2 sine x.
Okay. In black, I will graph the sine x, two periods of it.
Okay.
With that being 2 pi, and that being 4 pi.
Okay.
1, and that's -1. And if you don't have this memorized, it's a good idea to memorize it. That's the parent function. In fact, that's actually considered one of your 10 elementary functions that you should have memorized. And of course, it goes negative also. But since they said graph two periods only, I graphed the two positive periods. Now, what's the consequences of the 1/2 for g of x, which I'll graph in red?
Its amplitude is different.
That's basically a vertical stretch or shrink. What is it in this case?
It's a shrink.
Okay. So I'm going to graph it. How?
You would draw a 1/2 on the y-axis, and then that is how high you would make your humps. In
other words, it doesn't really change any of the other key points. It doesn't change the period. It only changes the amplitude both below and above the x-axis.
Yeah.
So it does change the shape. Stretches, shrinks, change the shape of the curve. Whether they're
Mm-hmm.
vertical or horizontal, they change the shape of the curve.
Yeah.
Shifts do not. If I were to do a phase shift of sine of x, it would look exactly like the black curve, only it would either be shifted left or shifted right.
Mm.
Okay, what else you got?
Okay.
I want to erase that, yeah.
The next one is f of x is cosine of x, and g of x is negative 1/3 cosine x.
It's actually pretty proper to think of these as transformations in the same way you did transformations of polynomials. There really is no difference. I've always been a little bit surprised that they teach it differently because, to be honest with you, they do teach it differently. Although it sounds like they're changing a little bit.
Possibly.
Well, I've had a couple of students lately that they're starting this section out talking about transformations instead of
Mm-hmm.
this new sinusoid function that's completely different. And it's not. Everything in this sinusoid function is a transformation. A is a vertical stretch or shrink. B affects the horizontal stretch or shrink. C is a horizontal shift and D is a vertical shift.
Okay.
Okay, now what I've drawn in black there is 2 periods of the cosine curve. And it also goes up to 1 and down to -1.
Yeah.
So we've got two things going on here. What are they? With
A
with g of x. In other words, how does g of x, how is it a transformation of cosine of x?
it is a flip on the x-axis, or like a reflection, I guess.
Okay,
And then it is a vertical shrink of 1/3.
okay, good. So I'm going to put 1/3 there. I'm going to put negative 1/3 there. And I'm going to do the reflection first. You always do reflections first, whether they're over the x or the y-axis.
Mm-hmm.
But everything else, I'm going to go through those 0 points. In other words, when you reflect about the 0 points, it goes through those. Okay, so
Okay.
I could do this in 2 steps, but I'm going to do it in 1 only. The period is not being affected, meaning that the length of 4 pi is going to be the same in the red as it is the black. In other words, B is 1 in both. And
Mm-hmm.
it's important to know that B is always 2 pi over the period, which implies the period is 2 pi over B. Okay, so in both of these cases you gave me, B was 1 in all 4.
Okay.
And that means the period has not changed. One period was 2 pi, and it's still 2 pi.
Okay.
Okay. Now, generally when I'm tutoring this stuff, I like to do each transformation separately in a different color. So maybe the first one I might have done would be the negative sign. Of course, the negative sign is, as you said, it's just a reflection of the parent function. over the x-axis. It's a vertical reflection. But then the 1/3 changes the shape, reducing the amplitude by 1/3. So the green would just be negative cosine x. The red is a negative 1/3 cosine x.
Okay. Okay.
What else?
The next one is f of x equals sine of x and g of x equals -8 sine of x.
Notice how I determined two periods.
Mm-hmm.
In other words, one period is the point from where I start headed up to where I finish headed up.
Yeah.
And the other one, same thing. I'm starting heading up, I'm finishing heading up. You can also determine periods by the distance between peaks or the distance between valleys.
Mm-hmm.
But definitely you want to know how you get one period.
Mm-hmm.
What two things does this have going on for it?
It has a reflection in the x-axis and a stretch of 8, a vertical stretch of 8.
Yeah, all right, so let's make that 1. Let's make that -1. This time I'll do them separately. There is the reflection only. Remember, reflections, if they go through 0, they have to go through 0 on the reflection also. In other words,
Mm-hmm.
the x-intercepts don't change on the reflection. And
Yeah.
now to go, I'm just going to draw the same curve between the same points, only those are going to be my end points. In other words, I'm going to draw the green curve. Don't need this one down here. So it's the green curve, only vertically stretched. Still goes through all the 0 points.
Yeah.
Like that.
Okay. Okay, I see how that gets. And the values at the top. Okay.
Yeah, in other words, instead of going from -1 to 1, it goes from -8 to 8.
Hmm. Okay.
Okay.
Okay. Well, the next problem deals with changes in the period.
Okay.
So f of x is sine of x, and g of x is sine of 4x.
Now notice here there's no parentheses. So there's no consideration for those two different formats.
Mm-hmm.
All we have is b is equal to 4. Okay. What's that make the period? Before I can graph it, I've got to know what the period is.
2 pi over 4 reduced is pi over 2.
Yep.
Okay. Yeah, that's a short period.
Yeah, let me think here. Yeah, I can do it like this. Hold on. sure I can get 2 periods on my screen.
For this one, you only need to do 1 period.
Oh, okay, good.
Sorry, I forgot to mention that.
That's okay. 1 period makes it a lot easier. Okay, normally that goes to 2 pi. Key consideration. Well, the new period, which I'll draw in red, goes to pi over 2. So I've got to draw the entire curve from 0 to pi over 2.
Okay.
The first thing you want to get used to doing is quartering these. So I'm going to quarter that distance up. That point's pi over 4. That point is pi over 8. And that point is 3 pi over 8. Okay? That's always your first step when you're dealing with a period difference.
Okay.
Is list the beginning and the end of the period and then quarter it up. Because now I know that these quarter points, in other words, above the pi over 8, it reaches its maximum there, comes back through the x-axis there, goes down to its minimum there, and comes back up to meet the x-axis there. So is all I have to do is draw the sine curve through those x's, and there you have it.
Okay.
It still goes to 1 and minus 1, but you can see the shape of the curve is considerable. And notice what else? That is a horizontal squeeze by a factor of 4, is it not? In other words, if you knew nothing about sinusoid functions, but you knew about transformations of polynomials, that's what you would say, is that's a horizontal squeeze. Sine of 4x is a horizontal squeeze, and that's exactly what happened. It's like we pushed in this direction on the end point, like an accordion, and squeezed that sinusoid function by a factor of 4. Didn't change the amplitude, didn't change its starting position, any of that.
Okay.
But it did change its shape.
Okay. The next one is
it sine or cosine?
Sorry, hold on, my phone locked. I have all the, we have an online textbook now.
Oh, okay. Only reason I ask is I don't know whether to go to another page and just erase my red. We can start.
It's going to be cosine.
I figured.
Yeah. So the next one is cosine of x is f of x. F of x equals cosine of x. And then g of x equals cosine 1/5 of x.
1/5?
Yeah.
Okay. Is that going to be a squeeze or a stretch? And is it horizontal or vertical?
It'll be a horizontal stretch.
Correct. So first of all, b is 1/5, making the period
what? Period be 2 pi over 1/5. So then you just multiply that by 5, so it'd be 10 pi.
Uh-huh.
Okay.
I'm going to call that 2 pi, going from 1 to minus 1. And in order to draw this curve, I need to quarter that up. I don't need the dimensions so much, But you'll notice why quartering that up is so important.
Yeah, because then you can draw your...
Points. It's your maximum point, where you cross the x-axis, your minimum point, where you cross the x-axis again, and where you end.
Mm-hmm.
Okay? So that's cosine of x.
Okay.
Period of g of x is 10 pi. So I've got to draw the cosine curve between -1 and 1 going out to 10 pi. What's my first step?
Quartering it up or halving it.
So when you quarter it up, first you do half.
Half would be 5.
Okay.
Half of that, would it be 3 pi over 1?
No, what's half of 5?
5 halves. 5 pi over 2, okay.
Yeah, sorry, I didn't mean 5x, I meant 5 pi.
No worries.
And this one here?
6 pi, so that would be 7 pi over 2.
What's halfway between 5 pi and 10 pi?
Like 7.5.
Which is 15 pi over 2.
Oh, okay.
And generally it's better to use improper fractions here rather than say that's 7.5 pi.
Yeah.
In the same way, this is 2.5 pi, but it's easier when you go to quarter stuff up to leave it as ratio. Okay. So now what I know is my starting point is there. This is where I go through the x-axis for the first time. This is where I hit the minimum. This is where I go through the x-axis for the second time, and I come back to my starting spot. So now you just have to draw the shape of the cosine curve through those points, and there you have it.
Okay.
And this process, this methodology that we've gone through is the one you always want to go through, which is to figure out the ending point, which is your period if there's no phase shift.
Yeah.
And then quarter it up. Quartering it up is vital. You can't really begin to draw that red curve until you've quartered it up.
Okay.
Okay?
Okay, the next one is a sine graph. And the first is sine of x, fx equals sine of x. Second one is g of x equals sine 1/4 of x.
So B is 1/4. What's the period?
Period would be 8 pi.
Okay. I think you know what we're going to do here.
Yeah.
Exactly what we did on the last one.
Mm-hmm.
I'm going to draw the sine curve between that. And then since the period is 8 pi, I'm going to go out here to 8 pi. What's the next step?
Quartering it or halving it, so it'd be 4 pi. And then quartering it would be 2 pi and 6 pi.
And now, I've always found it easier if I make these x's. Because once I make the x's, I know how to draw the curve through those x's.
Okay.
Not sure that it's an absolute necessary step, but it sure doesn't hurt. In other words, you can get a little confused trying to draw the sine curve if you don't have those x's.
Yeah.
But with the x's, I know I got to go through there, I know I got to go through there, I know I got to go through there, I know I got to come back to there.
Okay.
Okay. And you'll find that when you start working with phase shifts, it's really important to do it this way.
we've
To know your
started.
starting spot and your ending spot. Now, so
Uh,
far, everything we've done, we've started at 0 and ended at 8 pi or 10 pi or something like that. But the moment you introduce phase shifts, then your starting spot is liable to be like minus 3/8 pi, and your ending spot might be 17 pi divided by 8 or something like that. And then quartering
mhm.
it up becomes a little more difficult.
Yeah.
Is the next one sine or cosine?
The next one's actually a word problem.
Okay.
So it is um, the contralto vocal type includes the deepest female singing voice. That's kind of just irrelevant. Um, okay, some contraltos can sing as low as the E below middle C, which has a frequency of 165 hertz. Write an equation for a sine function that models the initial behavior of the sound wave associated with E3 having an amplitude of 0.15.
So those are the only things we have in terms of numbers?
Yeah, that's all it's given.
Okay. Well, you don't get I don't get frequency questions very much from students, but the fact is the frequency is the reciprocal of the period.
Okay.
Okay. So I can say that the period is 1 over 165.
Okay.
So my curve is going to be 0.15. And they did say sine.
Yeah, sine.
Now, b is equal to 2 pi over the period. And my period is 1 over 165. So b must be 330 pi.
Okay. Okay, I see how it goes.
Do you have answers for these?
Not for these ones. He has a teacher's book.
Okay. I'm pretty sure I might be off on my units, but I don't think so. I don't think
That's okay.
they didn't give you any conversion factor for hertz. And
No, no.
okay, since they didn't give you a conversion factor, then I'm 95% sure this is correct.
Yeah, they just want an equation modeling it.
Right. The frequency is definitely the reciprocal of the period. So
Mm-hmm.
I know I have a frequency of 165. I have a period of 1 over 165. And then from that, I can figure out what b is. Remember, that is b. The coefficient in front of x is b.
Okay.
Okay, so if I plug in the period, flip and multiply, I get a b of 330 pi.
Okay. Well, the next four questions are the same kind of aspect
Okay?
without word problem. So they give you the frequency and the amplitude, and they just want you to model an equation.
Okay?
So the first one is a frequency of 440 and an amplitude of 0.3.
What's my function going to be?
Your period is gonna be 1 over 440.
Okay.
The b is gonna equal 2 pi over 1 over 440. So that comes out to 880 pi. So then with an amplitude of 0.3, your equation is going to be 0.3 sine 880 80 pi x, right?
That's right. Absolutely.
Okay.
I'm curious about something. If you
Mm-hmm.
left off the 0 like I did, would you lose points ever?
No, I don't think we do.
No, I wouldn't think you would either.
As long as you put the point.
Yeah, and I'm continually amazed at how many students I have that continue to put the 0 in front of the decimal point, which
Huh.
to me seems like a waste of lead,
Yeah.
right? I mean, the moment I put a point with nothing in front of it, the 0 is presumed.
Yeah,
So
well, I think that's what our teacher
0.3 is
does
the
too.
same as 0.3. I don't need the 0. That's the way I look at it. Now, some teachers may be really strict about it, and I know that in general, the entire school system teaches 0.3. But I've always felt like it was a waste of lead and time to write it. So
I see, yeah, I see how that comes up.
when I write 0.3, it can't be anything but 0.3. If it was 1.3, I'd have to put a number on it.
And I think that's why our teacher lets us do it that way too, actually.
Yeah, it's kind of like saying the square root of 2. There's a 2 there, but we don't write it. I don't need to write it. As long as I have a
Hmm.
radical sign with no number, it implies 2.
Yeah.
If I want the cube root of 2, then I got to write it like this. And interestingly enough, there's not very many things in math that imply a 2 if you don't write anything, but radicals do.
Hmm.
Notice that most math, if you don't write anything, it implies a 1. You know, if I write x, that means x to the 1 power.
Hmm.
But with radical signs, it means the second root. Just curious whether there was similar consideration
Yeah.
for this. So,
Mm.
okay, so I think you got this down pretty good.
Yeah, actually, while we were talking, I finished the next four problems.
Okay, good. I was going to say,
Yeah,
if you have some
to
other,
move on.
let's move
So,
on if we can, just because if we can, let's
mhm.
cover phase shift. Phase shift's the toughest
this
one.
this is actually what's just about to go into.
Okay.
So, it wants us to state the amplitude, period, frequency, and phase shifts, and vertical shift of each function,
Okay, good.
and then um, graph a period of the function,
Okay,
or two periods if needed, is what it said.
okay. I don't know why that would
Um,
ever be needed.
yeah, I don't know. I don't know why I put that either. I was kind of curious on that.
I don't think that would ever be needed. You can show everything you need to show with one period.
So the first one is
Go ahead. Yeah.
y equals 3 sine of x minus pi over 4.
All right. The way I like to do these is start out by listing all of your A, B, C, and D. Incidentally, are these the four variables you use?
Yeah.
Good. A is what?
3.
B is what?
2. Well, it's 1, so it'd be 2 pi.
Okay, so
Or just
it's
3
1.
by 1.
Now we figure out the period. That means the period is 2 pi. C is what?
Uh-huh. C is negative pi over 4.
Actually positive pi over 4.
Oh, yeah.
In other words, this, much like everything else in algebra, is always an x minus h. Think
Okay.
about quadratics, it's x minus h. Think about conic sections, it's x minus h, y minus k. You don't ever run into an x plus anything until you get to calculus. And then you see that for the very first time you see an x plus h. So whenever you're looking at something like this, know that the standard is x minus h, which makes the phase shift pi over 4, meaning we're going to shift it to the right pi over 4.
Okay.
And d is what?
D is 0?
Yeah.
Nothing?
So we really only have two things going on here. We have an amplitude shift and we have a phase shift. Now, there's a couple of ways to do this. I always used to do it a different way, but I have since discovered that the best way to do it is to start with your phase shift. In fact, I'm not even going to draw the sine curve.
Okay.
Here's my beginning point. Normally the sine curve would start right there. Where's this one going to start?
At pi over 4?
Where's it going to end?
2 pi, 8 pi over 4? No. 9 pi over 4, sorry.
That's all right. Quarter it up.
B pi over 4, sorry, just trying to look at 9.
Easiest way to do this is to add those two numerators and divide by 2.
So 10 pi over 4 divided by 5 pi over 4?
And then what goes in between these two?
3 pi over 4?
And this one? Halfway between 5 and 9.
7 pi over 4?
Yeah. To where they all this easy.
Yeah.
Not normally all the same denominator. When you start getting into eighths and twelfths, quartering them up can be quite an algebra problem. This one, pretty easy. Okay. Amplitude means that instead of going up to 1, we're going to go up to 3 and down to -3. Now let's put our x's. I'm going to draw the curve in green. It's a sine curve, so it starts at the x-axis, goes up to its first high point at its first quarter point, comes back through there, goes down to there, comes back to there. And that's the most important part of those x's. If you happen to draw the curve in a funny fashion, the teacher will not take points off. In other words, if I would have drawn the curve like this, I would have still gotten credit. The key thing is those quarter points. Those quarter points are where it reaches its peak, where it goes back through the x-axis, where it goes to its minimum, and where it comes back to the x-axis. Now, if he only asks you to draw one period of it, that's fine. You're going to end up having to go both ways on these things. In other words, the next thing that's coming is they're going to show you charts, and you have to figure out what the sinusoid function is from the graph. Well, in this case, you'd be looking at something like that, okay? And they might show you 2 or 3 periods of the graph. And so the first thing you'd have to do is figure out the period, distance between that point and that point. It's a good starting spot. That shows you what the period is. Then that'll let you figure out B. And A is always this distance minus that distance divided by 2. Because when you start getting into real-life trig problems where they apply this sinusoid function to the tides or to somebody's breathing or to a simple pendulum rope swinging back and forth, anything that's periodic in nature, They're going to
Okay.
ask you to come up with the sinusoid function of it. In other words, they may tell you a problem like high tide comes in and it's 34 feet. I'm going to get a little ahead of here. I think you got a pretty good handle on this, so let me give you a little bit of advanced. High tide is 34 feet. Low tide is 14 feet.
Okay.
That tells you the amplitude. In other words, the amplitude is the highest point minus the lowest point divided by 2. So if you have these measurements given to you, you know the amplitude is 10. And it also tells you the vertical shift. In other words, the origin is not my origin. If I were given this problem right there, immediately I know that I have to draw my line of symmetry at 10. Now it's the sum of those two divided by 2. I got to draw my line of symmetry at 24. And it goes up to 34 and it goes down to 14. And I would draw the curve like that. So when they give you word problems, you can always figure out A and D by the maximum and the minimum values they give you.
Okay.
Another example might be where if you wanted to model breathing and they said that when you take in a full breath, your lungs are holding 8 gallons of air. When you breathe out fully, your lungs only have 2 gallons of air left.
Okay.
What's the amplitude? Well, it's the maximum minus the minimum divided by 2. What's the vertical shift? It's the maximum plus the minimum divided by 2. So whenever they give you word problems, it's really rather easy to solve for A and D. And then they might say that you breathe once in and out every 4 seconds. Well, that makes your period 4 seconds.
Okay.
So when they give you word problems, you can take everything and translate it to an A, a B, a C, and a D, and come up with the sinusoid function that represents that particular model. And that's pretty valuable. If you know what the sinusoid function is for tides, then you can predict what the high tide is going to be on March 20th or February 17th, as long as you know what the equation is that model tides. And tides are a very periodic phenomenon. And that's why this sinusoid function is so important, is because so many things in life are periodic. They follow a sinusoid or a cosine pattern.
Okay.
And even though this is called sinusoid function, you can as easily have cosine here as sine. In other words, if I put cosine in there, it's still a sinusoid function. It's just model it after the cosine. You've figured out by now, I'm sure, that the cosine and the sine differ by a pi over 2 shift. In other words, if you take the sine curve and shift it left by pi over 2, you end up with the cosine curve, starting at 0.
Yeah. Okay.
But that's where all this is headed, is how you take real-life problems and convert them to sinusoid functions, including a Ferris wheel that's rotating. Okay, when you get on a Ferris wheel, let's say the steps are right there, and you get on that Ferris wheel and it's rotating like that. Well, notice what you do. You go up to a peak, then you go down to the 0 point, and then you go down to the low. Well, what is that? That's a sine function that does that. But
Mm.
what if I were to get on the Ferris wheel down here? Well, now you go to the midpoint and then to a peak. Well, what function would I use here? Negative cosine. Negative cosine of x would start at the lowest point. It would go to the midpoint and go up to its peak, back to the midpoint, down to the low point. That's what would
Okay.
model that Ferris wheel action the best, would be a negative cosine function.
Okay.
Okay? I was trying to speed everything up because I was thinking we were done at 4, and I just remembered we're not done till 4:15. So what else do you have?
I have another one of those problems.
Okay?
So this one is, and this one it says you have to draw two periods of it.
Okay?
So y equals cosine of x over 3 plus pi over 2.
Is the b inside or outside the parentheses?
Inside.
So the very first thing we really need to do is to get it outside.
Okay.
Okay, and the reason is that pi over 2 is not our phase shift. We don't know what our phase shift is until that b is on the outside. The phase shift is pi over 2 divided by b. But
Okay.
the simplest way to see it is to factor out the 1/3. Now I have x. What's this become instead of pi over 2?
Pi over 6.
You got to make sure that when you put it back together again, it ends up being pi over 2. So it's got to be pi over 2.
3 pi over 2. Okay.
Notice that they're now equal. In other words, it's tempting to write pi over 6. That's honestly what I thought we had when I wrote this. But remember, we're taking the pi over 2 and we're dividing it by 1/3, which gives you 3 pi over 2.
Okay.
So now my b didn't change. My b always was 1/3. So whether it's inside or outside the parentheses doesn't affect b or the period. What it does affect is the phase shift. So once I've factored out the 1/3, now I'm looking at the phase shift. What is it?
The phase shift, is it just, it's 3 pi over 2?
Which way? In other words, whenever you're talking about horizontal shifts, and that's what a phase shift is, you need to specify whether it's to the left or the right.
Left. Negative.
Okay. Yeah, I can designate that with a negative. The left is actually a little more specific because it tells you which way to go. Period is what?
The period is 6 pi.
So when I grid this, I want to make sure I can fit 6 pi on there. So I immediately do that. Excuse me. Let me go backwards a second. I start with the starting point.
Okay.
I'm going to call the starting point right there, minus 3 pi over 2. That's where my cosine curve is going to begin. Where is it going to end?
It's going to end at 6 pi over 2. 3 pi over 2?
No, that's where the beginning is shifted from 0. In other words, the phase shift, instead of starting the cosine curve here and drawing it like that, I'm going to start it over here and draw it like that.
Would it end at just pi over 2?
Well, what's its period?
6 pi.
Okay,
Oh,
so
it's not
add
2
6
pi.
pi to its
Okay.
starting spot. Where's this ending spot?
2, 12, 9 pi over 2.
Good. Now quarter it up.
9 pi over 2. That would be 3 pi over 2?
Now, they ask you to graph this, right?
Yeah.
Okay. Well, let's see. If I add them together, I get 6 pi over 2 divided by 4. That's 3 pi over 2. Which is also 6 away from that and 6 away from that. The other way to look at it.
Mm-hmm.
Where's its next quarter point?
0?
Yeah, despite my drawing. Yep. And this quarter point here?
That would be at 6 pi over 2.
And it's okay to write it like that. Normally they might want you to change that to 3 pi. In other words, usually you simplify stuff, but in the case of trig functions, it's kind of nice to have the same denominator for everything.
Uh-huh.
Okay, so there's no amplitude, so I'm only going up to 1. I'm only going down to -1. I mean, there's no a other than 1.
Yeah.
So in red, I'm going to start the cosine curve, always starts at its maximum, goes down through its first quarter point, 0, hits its minimum at its second quarter point, comes up through there, and ends there. Now, pretty easy to connect the dots.
Mm-hmm. Okay.
And that is 0. And that's really the way you want to do all of these. And it doesn't matter if they give you an A and a D and a B and a C. You do them all the same way. It's just a little more complicated.
Okay.
Do you have one that's got all 4 things? 7 minutes, it'd be kind of nice to do one. If you have one that complicated, or give me the most complicated one you have.
Okay. The only thing that doesn't change is the amplitude.
Okay.
So this one is, amplitude and B, I guess. This one's got a lift.
Has a what?
I think a lift is what it's called.
A vertical shift? Give me the function, and then I'll know what you're talking about.
Yeah, it's a vertical shift. The function is y equals sine of x plus 5 pi over 6, then parentheses plus 4.
All right. The vertical shifts are the easiest things to handle of all. The very first thing you have when you have a D is draw a line of symmetry that is your new line of horizontal symmetry. In other words, whatever sine curve I used to draw about the x-axis, I'm now going to draw it about the y, or about that line of symmetry.
Okay.
So what's my low point and my high point going to be?
Your low point is going to be 3 and your high point is going to be 1?
High point's going to be 5.
Oh, 5.
That's what,
Sorry.
that's what you meant to say, I know. Okay, where's my starting spot?
Your starting spot is going to be a negative 5 pi over 6.
Okay, we'll call that right there. Where's my ending spot?
12 pi over 6. 7 pi over 6.
Quarter that up.
7 pi over 6. So the middle would be pi over 6.
2 pi over 12, yeah, pi over 6. You do that better than I do it. And this point here is what? Yeah, I got it on the wrong side too. Hold on a second. Let me do this a little different. Let me put my 5 pi over 6 a little bit further left. Minus 5 pi over 6 is there. And let's put my...
This one would be negative 2 pi over 6?
Yes, I think so. Let's see. So what was that again? That was pi over 6. And that point is going to be negative 2 pi over 6. And this point's going to be...
That point would be 4 pi over 6.
Now everything's pretty easy at this stage. In red, it's the sine, okay? The sine starts on the line of symmetry, whether it's your x-axis or this horizontal line. So that's my first point. At the first quarter point, I go up to my peak right there. At the second quarter point, I come back down through the line of symmetry right there. At the third quarter point, I go down to my minimum value, 3. And at the fourth quarter point, I come back to the line of symmetry. So that curve looks like that. Now, let's say they gave you that curve and said, come up with the equation of it.
Okay. Well, I would know immediately it's a sine curve.
Well, when you have to come up with the equation of a curve, you need to come up with A, B, C, and D. Well, we know A is 1. And I get that by taking 5 minus 3 and dividing by 2. So when they give you the curve, you can always come up with A by taking your maximum minus your minimum, divide by 2. And you can come up with D by taking your maximum plus your minimum and divide by 2.
Okay.
You come up with B by figuring out what the period of this thing is. The period is 2 pi. Since B is 2 pi divided by 2 pi, B is 1.
Okay.
And the phase shift is, we can look at the curve and see that we're looking at a sine curve that's been shifted left by 5 pi over 6. That makes C plus 5 pi over 6. So if I was given the red curve and I had to come up with it, I would have sine, B is 1, is, I should have said negative 5 pi over 6, which makes it plus 5 pi over 6, and then D is plus 4. So you're going to need to be able to go both ways, and that's the way to go both ways. If they show you, if they show you the function, you can draw the curve, and if they show you the curve, you can come up with the function. The key things about coming up with the function really are this A and D. I mean, just remember that you get A from the maximum minus the minimum divided by 2, and you get D from the maximum plus the minimum divided by 2.
Okay.
So if you had a tides problem, you'd use that. If you had a breathing problem, you would use that. Anything where you are given the maximum value and the minimum value is going to allow you to come up with both A and D.
Okay. Okay.
All right.
Cool.
I would imagine the next time we have a session, you'll probably be dealing with those kind of problems. In other words, where
Yeah.
I'll give you word problems and say, what's the sinusoid function that models this particular activity?
Uh, okay. Okay, cool. Well, thank you, Mr. Cohen.
You're welcome. I will talk to you next time.
Sounds good. Talk to you then.